Your potential is limitless. With the right mentor, welcome to the Dhanraj Sir Method, Living the Subject.
All right, let's talk about something pretty incredible. Right now, as you're sitting there, our planet is performing two, well, let's call them cosmic dances. And these two moves, they shape absolutely everything, from the sun coming up this morning to where you might go on your summer vacation.
So, have you ever really thought about that? Why do summer days just seem to go on forever? And how on earth is it possible that Christmas is a beach party in Australia? The answers aren't that complicated. It all comes down to two simple motions, a daily spin and a yearly journey that literally create the world we live in.
Okay, first up, let's get into the motion we experience every single day, even if we don't really feel it. We're talking about rotation. This is Earth's 24-hour rhythm.
So what exactly is rotation? Well, just imagine a line, an invisible pole, going straight through the Earth from the North Pole to the South Pole. That's its axis. Rotation is just the Earth spinning on that axis. And here's the key detail. It spins from west to east. Remember that, because it's going to be super important in a second.
And get this is not some slow, lazy spin. No way. If you were standing at the equator, you'd be whipping through space at over 1,600 kilometers per hour. That's faster than the speed of sound. It's mind-boggling, right? The only reason we're not all flung off into space is good old gravity, holding us down.
So, what does all this spinning actually do? Well, the effects are huge. The most obvious one, of course, is day and night. But remember how I said it spins from west to east? That's exactly why the sun looks like it's rising in the east. We're just spinning towards it. This spin is also responsible for our time zones. And it even causes this weird, kind of complex wobble called the Coriolis effect, which is powerful enough to steer giant hurricanes and ocean currents. Pretty amazing.
And here's a super fun fact for you, a totally wild side effect of all this speed. That spinning creates a force, a centrifugal force, that actually makes our planet bulge out a little bit at the equator. That's right, the Earth isn't a perfect ball. It's actually a little chubby around its middle, kind of like a squished sphere.
Okay, so that's the daily spin, the rotation. Now, I want you to zoom out with me, way out. Let's look at the bigger picture, our planet's much, much longer journey. We're talking about its year-long trip around the sun. And that, my friends, is called revolution. So this massive trip around the sun, that's what we call revolution. Now, if you look here, you can see that Earth's path, what we call its orbit, it's not a perfect circle like you might draw in school. It's actually a little bit stretched out, like an oval. The technical term is an ellipse. And what that means is that our distance from the sun isn't always the same. It changes as we go through the year.
And this oval orbit has two really important points. Around January 3rd, we hit something called perihelion. That's when we are closest to the sun. Then fast forward to about July 4th, and we're at aphelion, our farthest point. Now listen closely because this is a big one. We're closest in January and farthest in July. Lock that away in your brain. It's about to become really, really important.
Okay, so what's the deal with leap years? That extra day we get in February sometimes? Well, it's actually pretty simple. See, one full trip around the sun, one revolution, doesn't take exactly 365 days. It's more like 365 days and 6 hours. So what do we do with those extra 6 hours? We just let them pile up. After 4 years, 6 times 4 is 24 hours, a whole extra day. So, boom, we stick it on the end of February. It's a clever little calendar hack to make sure our seasons don't drift out of sync.
All right, so we've got the daily spin, rotation, and we've got the yearly journey, revolution. Now, let's put them together, because when you do, you solve one of the biggest mysteries of all. Why do we have seasons?
Now, I bet I know what you're thinking. It's obvious, right? We have summer when we're closer to the sun and winter when we're farther away. I mean, it just makes sense. It feels right, doesn't it?
Well, it's wrong. It's one of the biggest science myths out there. Remember what I told you to remember. Perihelion, our closest point to the sun. That happens in early January. For anyone in the northern hemisphere, that's the dead of winter. So there's no way our distance from the sun is the reason for the seasons.
So if it's not the distance, then what is it? The real answer, the secret ingredient to the whole thing, comes down to one single number, 23.5 degrees. You see, that imaginary pole we talked about, the Earth's axis, it's not perfectly straight up and down. It's tilted. And that little tilt, well, it changes absolutely everything.
Okay, so here's why that tilt is the whole ballgame. Think about it like this.
When your half of the planet is tilted towards the sun's rays are hitting you directly. It's like holding a flashlight pointed straight at a wall. You get a small, bright, intense circle of light. That's concentrated heat. That's summer. But when your part of the world is tilted away from the sun, those same rays come in at an angle. It's like shining that flashlight at an angle. The light gets spread out over a much bigger area, and it's way less intense. That's weaker heat, and that is winter.
So this constant tilt, combined with our year-long journey around the sun, gives us 4 key moments in the year. 4 special dates that officially kick off our seasons. You've heard of them, the solstices and the equinoxes.
This image here shows it all perfectly. Take a look. As the Earth makes its trip around the sun, notice how that 23.5-degree tilt is always pointing the same way in space. It's like it's locked on to a distant star. And because of that, you can see that for one part of the year, the northern hemisphere is leaning into the sun, getting that direct heat. And for the other part of the year, it's the southern hemisphere's turn to get a suntan. So let's just quickly break down the difference. A solstice, that happens when we're at our maximum tilt, either towards or away from the sun. That's what gives us our longest and shortest days of the year. An equinox, on the other hand, that's the halfway point. That's when the sun is shining directly over the Earth's equator. And for one day, day and night are pretty much equal all across the planet. Let's take June 21st, for example. Around that time, the northern hemisphere is tilted as far as it can go towards the sun. This is the summer solstice, the longest day of the year for the north. It gets so extreme that if you go way up north to places like Norway inside the Arctic Circle, the sun literally doesn't set. They call it the land of the midnight sun for a reason.
Okay, now let's jump ahead 6 months to around December 22nd. The whole situation is flipped. Now the northern hemisphere is tilted away from the sun. That's their shortest day, the winter solstice. But the southern hemisphere is now getting all that direct sunlight. And that is exactly why Christmas in New Zealand or Australia is a summer holiday, with people heading to the beach.
And right in between those two extremes, you've got the equinoxes. They happen around March 21st and September 23rd. On these 2 days, the Earth isn't tilted towards or away from the sun, it's kind of tilted sideways. So the sun's most direct rays are hitting right on the equator. It's a perfect moment of balance. Day and night are about 12 hours long pretty much everywhere on the planet, and they kick off the start of spring and autumn.
So there you have it. That one little 23.5-degree tilt is basically the conductor of our planet's orchestra, creating the rhythm of our entire world. Which leaves us with a really cool final question to think about. What if that tilt wasn't there? What would life be like if the Earth's axis was perfectly straight, at 0 degrees?
Well, for one thing, there would be no seasons. None. The weather where you live would just be the same all year long. And every single day, no matter where you were on the planet, would be almost exactly 12 hours of daylight and 12 hours of darkness. Kind of strange to think about, right? It just goes to show you, our beautiful, dynamic, ever-changing world is all thanks to a simple, steady little tilt on our big cosmic dance.